Let's see if we are recording. Okay, we are recording. So today the idea is that we are going to introduce what is a firewall. Okay, so as I was telling you, a firewall is a device, or it can be a software firewall also, that will allow us to filter what we suppose to be malicious traffic. So we define rules in firewall, and the rules say what to do with the traffic that match the rules. So for example, common rules is let the packet that match the rules to pass, or let's drop them. So here I have some small slides from Vipin Gupta that say that you can buy an appliance. For example, Cisco have a family of firewall that is called the ASA family. So you can buy it and put it, for example, in a rack in your wiring closet. Checkpoint is another very famous manufacturer that have firewall. Microsoft also have some firewall that are called ISA. We have in Linux, we have open source firewall. So one of the oldest one, and the one that we are going to see, is IP table. So of course, I have no cost, which is the benefit, and it's pretty complete as a firewall. So in IP table, we have different tables. For example, there is a table that is called filter. And this is a table that I'm going to use today. And it's a table that allows me to filter packets according to rules that I can define. And for each table, we have some chain that are associated. For example, the table filter have three chains. One chain is called input, which will be the traffic that arrive to the firewall. Output, the traffic that is generated by the firewall, and forward, the traffic that's going to pass through the firewall. So it's not generated by the firewall and it does not end in the firewall. It just has to be forwarded by the firewall. Once it is inspected, we classify it as benign or normal traffic. So why IP table? IP table is open source, so it's free. Also, it is very complete and flexible, and it's a stateful firewall, as we will see. So there are different types of firewall. For example, we have firewall. I talk about tables, and I say that there is a filter table. The filter table allows you to filter traffic. There is another table that is called the NAT table. So the NAT table is when you want to implement NAT. For example, source NAT and destination NAT. So source NAT will be when you have different computers with private IP addresses and you want to give them access to the internet. This is called source NAT because you are going to translate the source IP address. Destination NAT is when you have a server in your company, but this server, here is the server, sorry. This server have a private IP address. So you want the internet, the computer that are outside your company, to access this server. So you need to translate the destination IP address. So for the outside world, you will advertise a public IP address for the server, but inside the IP address of the server at the end is a private IP address. Okay, there is a little more information about it here. I'm going to pass it because the table that we are going to study today is the table that is called filter and will allow us to filter. So let's say that we have those devices and we install IP table in the device that is in the middle. So that will be the firewall. So as you can see, it has several interfaces. The idea is that it receives traffic check the traffic and decide what to do with the traffic. So what will be input traffic? Input traffic is traffic that arrives to the firewall. So the destination IP address is one IP address of the firewall. For example, if this computer C2 sends something to the firewall, that will be input traffic for the firewall. Or if client 11 or client 31 sent packet to the firewall, that will be input traffic for the firewall. So it's traffic that arrives to the firewall, and the firewall have to consume this traffic. As you can see here, for example, this arrow show that the traffic comes from C2 to the firewall, or this arrow that is set here and show input, show traffic that's come from, for example, C31 or C11, client 31 or client 11, and go to the firewall. So what is output? Output is the traffic that is generated by the firewall to another devices. For example, if the firewall sends something to C2, that will be an output traffic. It's go from the firewall to some device outside the firewall. So for example, if the firewall generate traffic for client 11, that will be also an output traffic. Or from the firewall to client 31, that will be an output traffic. And what is a forward traffic? A forward traffic is a traffic that's passed through the firewall, but it's not originated by the firewall and it's not destined to the firewall. So for example, let's say that C2 have to send something to client 11. So of course, the packet have to pass through the firewall. In this case, it will be seen by a chain that is called forward. Forward is that I receive on one interface and I forward it on another interface. For example, here, I receive it on interface ETH1 and I forward it on an interface ETH0 to client 11. So if client 31, sorry, have to send something to C2, it will also go through the forward chain of the firewall, because this traffic is a forwarding traffic. It means that it enters interface ETH0 of the firewall and it have to exit interface ETH1. So all of you have taken the networking class, or in this moment in the networking class. Okay, so we define the TCP/IP protocol suite in the networking class on the OSI model. So here we have information of the OSI model. And as you remember, the OSI model has 7 layers. The physical layer, which is layer 1, the data link layer, which is layer 2. Then we have the network layer, which is layer 3. Layer 4 is the transport layer. The session layer is layer 5. Layer 6 is the presentation layer. And layer 7 is the application layer. So we define addresses in 3 layers. So in layer 4, which is the transport layer, we have some addresses that are called port. So here you can see S port for source port and D port for destination port. So I'm pretty sure you know some ports. For example, if I ask you what port a web server listen to, what port? In which port a web server is listening petition from client? Port 80 or port 443. So if I don't use secure HTTP, it will be port 80. But if I use secure HTTP, it will be port 443. So a web server can listen on those ports. For example, if I have a secure share server, it will listen on which port? Port 22. Okay, so we'll see a list of ports that are important. Okay, in the network layer where we have IP, the Internet Protocol, we will talk about IP addresses, the source IP address and the destination IP address. For example, this is an IP address, 170.24.0.31 is an IP address. So in layer 2, the data link layer, we will talk about MAC addresses. So we will have the source MAC address and the destination MAC address. Okay? And MAC addresses are sometimes written like that. So 00-50-56-C0-00-A1. If you don't use the dash, you can use also the colon. And there is another way to write MAC addresses is instead of separated the MAC addresses by byte, we can do group of 2 bytes and put a dot. So 2 byte dot 2 byte dot 2 byte. A MAC address has 6 bytes, as you can see, no, and as you should remember from the class of networking. So the PDU in the data link layer is called a segment. And in the network layer, it's called a packet. And in the data link layer, it's called a frame. So the PDU in the transport layer is segment. In the network layer, it's a packet, and in the data link layer, it's a frame. Okay, let's see other things that are interesting for us. Okay, so the ports. The port from 0 to 1023 are called well-known port. Normally, most of the people that work in networking know about 20 ports. Anything that is not common, you just Google the port, or even the machine have information about a port and a service name. There is a file that is called /etc/services that will give you the equivalence between a port and the name of a service. So the port that go from 1024 to 49,151 are called registered port, and all the other ports are called dynamic ports. So here is a list of ports that people normally know. So port 21 is for FTP. What is FTP? File transfer protocol. So file transfer protocol is over what? Over TCP or over UDP? It's an application protocol. So since it's an application protocol, it is over a transport protocol. Which transport protocol is using FTP? UDP or TCP? So FTP is using TCP. Can you please give me some example of transport protocol, famous transport protocol that use TCP? So HTTP, for example. What else? Telnet. What else? Secure Shell. What else? SMTP, Simple Mail Transfer Protocol. What else? POP3. What else? IMAP. Okay, there are a bunch of protocols that use TCP as a transport protocol. Give me some application protocol that use UDP as a transport protocol. Trivial FTP use UDP. What else? DHCP, Dynamic Host Configuration Protocol, use UDP. What else? SNMP, Simple Network Management Protocol, use UDP in the transport layer. DNS, use UDP. Okay, so Secure Shell, the port of Secure Shell is port 22. The port of Telnet is 23. Do you know what is the difference between Telnet and Secure Shell? Yeah, Secure Shell use end-to-end encryption. You are right, and Telnet doesn't. So Telnet was done many years ago when security was not an issue. So all the information that is sent through Telnet is in clear text. Secure Shell came years after when security was a problem. So with Secure Shell, we will have authentication, we will have privacy, and we will have, what else? Integrity. The CIA CIA mean that. So C mean what? It's the same three letters, but we use also this acronym in cybersecurity. Confidentiality, you're right. I is integrity and A, no, authentication. So CIA is confidentiality, integrity, and authentication, which is things that we need in all communication through the internet. Okay, so DNS, domain name service, use port 53. Remember that DNS use UDP. Trivial FTP use port 69, and trivial FTP is also over UDP. HTTP, the hypertext transfer protocol, use port 80, and it is also over TCP. Post Office Protocol 3 use port 110, and it's also over TCP. IMAP use port 143, and it is also over TCP. And HTTPS, secure HTTP, use port number 443, and it is also over HTTP. It's HTTP with TLS, Transport Layer Security. Okay, so let me see what else. I think is the only thing that I need to tell you. Okay, so we are going to do a lab today. Let me show you what we are going to do. We are going to do this lab. So in this lab, as you can see, we have a router firewall. It will do both things. It will be what router, so it can forward packet from PC2 to PC11, for example, or from PC31 to PC2. So it will forward. As you can see, you have two interfaces, and it will be firewall also. It will, every time that traffic will pass through it, it will inspect the traffic and decide what to do with the traffic. It let the traffic pass, or if to drop the traffic. So to do a small practice, what I did is that, for example, you see PC2, we will install 4 servers in PC2, a secure shell server, a web server, a FTP server, and a telnet server. So in the firewall, we are going to install also some server. As you can see, we install exactly the same one. In PC11, we are going to install the same 4 server. And here in PC31, we are going to install only 2 servers, a web server and a FTP server. Here we are going to install IP table, so we can inspect packets. We will have a firewall, so we can filter packets when they pass. And in the computer, we are going to create some user. For example, in PC2, we are going to create 2 users. One user is called John, and the other user is called Amelia. Then in the firewall, we will have a user that's called Robert and Michael. Then in PC11, we will have 2 users, David and Jennifer. And in PC31, we will have 1 user, which is Thomas. Those are normal users. We always have the root user. Here we have a switch, as you can see. So I want to do this topology, and of course, the easier way to do that is with virtualization. So we are going to use GNS3 to do this topology. And all the devices at the end are going to be Debian boxes. So even the firewall, it will be a Debian box where I'm going to put 2 interfaces. So by default, when you grab one from the library of GNS3, it have 1 interface, but we will have a second interface in the firewall. So what port is going to be open in this device, in PC2? Sorry? what port? What port? What TCP or UDP port? Not what interface, no? So since I have here, for example, our secure shell server, what port will be open? 22. I have a web server, what port will be open? So this web server will only use HTTP, will not use secure HTTP. So port 80, correct. I have a FTP server, which port will be open? 21. And I have a telnet server, which port will be open? 23. Okay? So we will see that in the devices. Okay. So I need to do this topology. So I'm going to make a difference at the level of the two screens, because otherwise I will not have enough space. So let me do that. Maybe extend this display. Should be okay. Okay, doesn't work. So let me try something different here. I have to do extend this display. I don't have choice. So let me see. Okay, keep. And let's see if I can use it. So we will keep here the network diagram. Let me see if I can. If I do that, it's appearing in both screens. So I will just keep it like that. It bigger. And in the other window here, I'm going to open GNS3. So, oh, do we have GNS3 here? Did I install GNS3 already? I'm not sure I did. So we might have to go to the internet and bring it from the internet, no? Oh, let me see if I have it in the pen drive. Wow. Somebody have GNS3 on pen drive? No? Oh. Let me see if it is there. I'm not sure, maybe you might be right. Yeah, let's see if it is there. That will save the. Oh yeah, it is. So let's use this version 10. Perfect. I say it doesn't find it here. Okay, this one, at least we have one version. That will make the trick for us. Okay, so the user is Eric and the password is internet2 of this virtual machine. I want to start GNS3, so I just click on this chameleon. Let's call this, for example, IP table 01, because it's the first exercise that we are going to do of IP table. So this is the name of the project. So, oh, there is something that the recording will not have both. So I might just not do that because I'm recording. I'm learning, still learning with this setting here. So let's duplicate the display. Okay, so I will put them side by side. I will put the network that we want to realize here and GNS3 here, because otherwise the recording will not be good. Okay, so what do I need to do here? I need 1, 2, 3, 4 PCs. So I'm going to grab here in the end devices, I'm going to take a Debian 10 and I'm going to drag it here. And this will be, for example, PC2. Okay, I need other PC. So what I can do, I can duplicate this PC. So let me duplicate it. Let me duplicate another one. And let me duplicate another one. So we will have PC2. We need PC11 and PC31. So let me call one PC11. And another PC31. And this guy is going to be the firewall. So let me change its name to firewall. Okay, so the image that we have over the firewall is not the best one, but GNS3 allows us to change the graphical representation. So what can I do here? How do I change I would like to have an icon like that for the firewall, for the router firewall. It does both functions, routing and firewall. So how can you change the icon? So you right click on it, you change the symbol. So I'm going to go to the classic symbol and I'm going to find the symbol that corresponds to both a router and a firewall. It is there and I'm going to click OK and I will have what I want. So the first thing that I need to do is to install additional software on those devices. They don't have, for example, they don't have a secure shell server. They don't have a FTP server. So I need to install from the Debian repository. I need to install the required software. So I need to connect them to the internet. How do I connect them to the internet? Who have an idea? So there is a cloud that is called NAT. This cloud have two functions. It have a DHCP server and it have a NAT server. And it will give me access to the internet. So I need to connect those 4 devices to the NAT cloud. And it have only one connection. So to do that, what I'm going to take is a switch here, and I'm going to connect all, let me call it SW to make it easier. SW for switch. And I'm going to connect all those devices to the switch. So they will have access to the internet. So I take this tool and I connect PC2 to any port of the switch, PC11 to any port of the switch, PC31 to any port of the switch, and the firewall to any port of the switch. And then I connect the switch to the NAT. So all these devices at the end are connected to a DHCP server. They will get the IP address through a DHCP server, and they will access the internet through the NAT server that is also inside this NAT device. So I'm going to stop them. I right-click them and stop them. So PC2 is booting. I can double-click PC2 to see the booting process. So it's like any booting process of a Debian device. And at one point, it will ask us what is our logging. I'm going to enter as root. And what is our password? Our password is tour. So I'm going to do the same thing with PC11. I'm going to start PC11, start PC31, and start the firewall. Double click on PC11, it will be booting. enter as root also because I need to do administrative task. So let's wait. The 3 devices are booting at the same time. It's a little slow because of that. Okay. So the user is root and the password is tour. Okay. PC31, the user is root and the password is tour. And here, the user is root and the password is tour. Okay. So in PC2, let me go back to PC2. I want to install a secure shell server. Do you have any idea how we can install a secure shell server? What are the commands that we need to type in order to install a secure shell server? Okay, so Debian define things that we call the repository. And the repository are servers that are in some place in the world where all the files that we might need when we install will be kept. So I need to install a software that is called OpenSSH-server. It will be in the repository. So the last time that I started this virtual machine was a long time ago. And at this time, I fetch a list of software that are available in the repository. But that was a long time ago. So they might have new version. They definitely have new version. So the first thing that you are going to do when you install software in the Debian machine is to fetch a new list of software that are available in the repository. How do you retrieve this new list? Yeah, apt-get space update. So we are going to do that, apt-get update. So it's going to connect to the repository that are already pre-configured, and it's going to bring the list of software that they have. And I will have a fresh list of software. So when I install a software in PC2, it will be the last version of the software. Let me do the same thing in all the devices, because in all the devices, I'm going to install some server. So I'm going to do apt-get update in PC11. I'm going to do the same thing here in PC31, apt-get update. And in the firewall, I'm going to do also apt-get update. So all of them have a recent list of software that are available in the repository. Okay, now let's go back to PC2. In PC2, I need to install, for example, a secure shell server. How do I verify if port 22 is open? Let me increase the font so you see better PC2. We are in PC2 here. Maybe I can, let me generate the PDF file of that, and we work only in the virtual machine. So I want to generate a PDF file. It is there. Okay, so we can forget Windows for some time and work only the virtual machine. So I'm going to drag this file inside my virtual machine. Okay, it is there. I'm going to drag also this file that I'm going to use. Okay, I'm going to maximize my virtual machine. Okay, so here we have the network that we want to do. And in this moment, I'm focusing on PC2. So I want to put in PC2 a secure shell server. But before we do that, I would like to verify that port 22 is not open. So how can you get the list of TC ports that are open in a device, in a Linux device? So there is a command that is called netstat. Network statistic -N for numerical, A for all, and T for TCP. Show me in a numeric way all the TCP ports that are open. So as you can see, there is no port that is open. And if I want to see the UDP ports that are open, I will put numeric all UDP. There will be only one port that is open, and this port is because we have a FTP client, DHCP client, sorry. So the DHCP client is listening on port 68. It's why we have one port open, because we have a DHCP client. Okay, so as you can see, when I type in this command, there is no port that is open in TCP, no port at all. No, let me redo the command again so you can see it. So N numerical all TCP, there is nothing open. So how do I install Secure Shell, a Secure Shell server? I do apt get install open SSH server. And this will install the open SSH server and all the dependencies. So if there are dependencies, it will tell me there are some dependency. Do you agree also to install the dependency? So look, here it says the following additional package will be installed. Those are dependency. Okay, they are required if I want to install the Secure Shell server. So it gives me, for example, some information. It says that when I finish installing the SSH server, it will use an additional space of the hard drive, which is, for example, here 7 GB, as you can see, 7,494 kilobytes, which is 7 GB. So do you agree to install Open Secure Shell server on the dependency? I'm going to answer yes. So it's going to bring the dev file from the repository and then install them. So here is downloading the dev file, and there is installing. So look, something that you already know. Do you see that? You know that. What is that? So Secure Shell also work with public cryptography, and it generates a pair of keys, a public and a private key. So when I connect to the web server, I can be sure the web Secure Shell server, I can be sure that I'm connected to the correct web secure to the correct Secure Shell server. No, not web, sorry, Secure Shell server. So it have a pair of key, and we can see the pair of key if we want. No, they are stored in a directory that is called etc Secure Shell. And look, we have here the keys. So let me show you, for example, the private key. You will see something that you already know. Okay, if I want to see the content, I can type cat. And as you can see, look, you see, begin open Secure Shell private key, and it is in base 64, and this is the end. So this is something that you already know. Okay, now that we install the Secure Shell server, how do I verify that port 22 is open? So I type the same command, which is netstat -numerical all TCP port. And look at what we can see. We can see that port 22 is open. So what does it mean here? Why we have two lines? So the first line is to say it is open in IPv4, and the second line is to say it is open in IPv6. So we have a Secure Shell server running here already. Okay, now we want to install, for example, a web server. What will be your suggestion? What web server can we install? For example, Apache. Apache is a very famous web server. So if I want to install Apache, what should I do? apt get install Apache 2. So it will show me all the additional dependency that it needs to in order to install Apache 2. and I will confirm that I want to install that, and it will install Apache 2. At the end of the operation, port 80 will be open. So we'll have port 22 and port 80 open. So look, it tells me, okay, additionally to Apache 2, I'm going to install all those additional package. Okay, so I say, yes, I do agree with that, download them and install them. So it's going to the repository, download them and install them, as you can see. So Apache, I've just started. So now if I type this command, I should see port 22 and port 80 open. So let's see. We have port 22 as previously for IPv4. We have port 22 for IPv6, and we have port 80. So when we have that, it will support both. It will support IPv4 and IPv6. And those are connection because I just did a apt-get install that are connection that are already closed. They will soon disappear. The ones that are important are the ones that are in listen mode. They are listening for client petition. So those ones in a few seconds should disappear. They have not disappeared for now, but if I keep doing that, they will disappear. Okay, still there, but still there. Okay, they disappear finally. Okay, so we only have 22, as you can see, open and 80. Now let's install a FTP server. So we have several FTP server, but we are going to install one that is called Pure FTP server. So Pure FTP daemon. And of course, it will open port 21. So it say, okay, there are some dependency. Do you agree to install them? I say yes. Download the dependency, the Pure FTP daemon, install everything. And if I look now, I should have 3 ports open, 21, 22, and 80. So look, this one will disappear. It's the same thing, is because I just download something, it's still there. But the important one are the ones that are in listen mode. So look at, this is 21. This is FTP. This is Secure Shell. This is HTTP. This is what? FTP. And this is Secure Shell, as you can see. Okay. And then I'm going to install a telnet server. Telnet listen in which port? Port 23. So when I finish to install the telnet daemon, port 23 will be open. So look, telnet is very light protocol. It didn't have any dependency. So when I asked to install telnet, since there were no dependency, it didn't ask confirmation. You just download telnet daemon and install it. So now if I check the port that are open, I should see port 23 open. As you can see, it is open. So remember, this is FTP. This is Secure Shell. This is telnet. This is HTTP. Okay, so this is for IPv4 and this is for IPv6. And this one is going to disappear. Maybe it's already gone, still there, but if you try it in 1 minute, it should be gone. Okay, because the ones that are important are the ones that are in the state listen. They are listening for petition of clients. Let's check if it's still there, but it will disappear. I will come back to PC2 in a few seconds and you will see it will disappear. Okay, I need to do the same thing in firewall. So let me install all the services that we need in firewall. So I'm going to do an apt-get install. Oh, before I do that, let's verify that the port that are open, there is no port that are open for TCP, as you can see. Let me increase the font. Now let's start installing all we need in the firewall. So apt-get install. Instead of installing one service at a time, I'm going to say all of them. So Apache 2, I need open SSH server. I need pure FTP daemon, and I need telnet. So of course, it's going to ask me if I agree to install all the dependency. I'm going to say yes. Now it's downloading all the dependency on the software per se and installing them. So at the end of that, it's generating the key of Secure Shell, as you can see. At the end of that, I will have the port that I'm waiting. So look, if you don't want to see them to appear, they will disappear. By the way, let's go back to PC2. Let's see if this entry have already disappeared. As you can see, it is over. So if you don't, those are there and they are in the state time wait. They are waiting to disappear. So if you don't want to see them, let's see if they are still there. They are still there. You can put L for listening. Show me only the entry that are in listening mode. Oh, it didn't do it. Show me the other also. Let me see the option -L. -L listening, show only listening socket. Strange, it doesn't work. Because it show me more. It should just show me the one that are in list. Here it show me only the one that are in listening, but maybe because yeah, they already disappeared. Okay, no problem. So this port is what? FTP. This port is what? Secure Shell. This port is what? HTTP. This port is what? FTP for IPv6, and this port is what? Secure Shell for IPv6, no? Okay. Let's install in the other two computers what we need. So for example, in a PC11, we need exactly the same thing. So let me go to PC11, it is there. And I'm going to do, let me increase the font so you see better. apt-get install. So we need the Secure Shell server, so open SSH server. We need the web server, so Apache 2. We need the FTP server, so pure FTP daemon. And we need the telnet server, so I'm going to put telnet daemon. At apt-get install, there is a missing S. Okay, I agree to install also the dependency. It will take care of everything. And in PC31, I just need two services. So let me increase the font of PC31. And I need the web server and the FTP server. So let's just install these two services. So apt-get install. The web server will be Apache 2. Of course, I can also install Nginx, no? It's another web server that is very famous. Okay, let's install Apache 2 and let's install pure FTP daemon. Okay, I agree to install the dependency. And at the end, we will see that only port 80 and port 21 will be open in this machine in listening mode. So if I do netstat -all numerical TCP, we can see that port 21 is open and port 80 is open, no? This is the port that are open in listening mode, waiting for clients. Okay, so as you can see, all the devices that I have here are text-oriented. They don't have a graphical user interface. So to check, for example, the web services, we need something like Chrome or something like Edge, Microsoft Edge, or something like Firefox. So which means that I will need a machine that have a graphical user interface. So not to install a machine that have a graphical user interface because it's required much more memory, much more processing power. I'm going to install a web client that will show us a web page in text mode. So there are several web clients, but let me, for example, install in PC2 one of the web clients. There is one that is called Links. There is another one that is called eLinks. So let me install eLinks. So apt-get install eLinks, that will be a web client, okay? So I say, yes, I want to install it on the dependency, and look, I can do e-links, for example, and bring me to the web page of JSU, jsu.edu. So it will go. This is the web page of JSU. So maybe we compare it with the graphical one, and you will see that it's the same one. But one is text-based, and it will not show any graphics, and the other one is GUI oriented. So for example, look here. It's a so future student. Do you see it here? Future student, about, apply. So it's a, we have the JSU logo. So that's that. Oh, the JSU logo is here. Then we have apply. It's here. Visit. It's here. I am. It's here. Then we have give. It's here. Then we have a search. So you see, we have exactly the same thing, but in a text mode. So if I want, for example, look at what we have here. We have the different college. So which means that in some place here, we have access to the different college, isn't it? Because it shows it in the text version.
If you click on that.
So it came from there. Oh yeah, so it came from there because we have A to Z directory, my JSU, it came from here. And we have the different college. So for example, if I want to go to the college, our college, the College of Science and Mathematics, I click here and it takes me to the college of our college. So it's say, let's see what it's saying about the college. So if I go to the College of Science of Mathematics, you have committed to Discovery, the College of Science and Mathematics. Okay, so you see it's a text version of a web browser. So we don't have to deal with graphical user interface. So we can install things that are very light. So I'm going here to exit e-links. So do you want to exit? Yes. And I'm not in e-links anymore. Okay, so I have a client. Let me install the client everywhere. So I just install it in PC2. Let me install it in PC11 also. So I'm going to do apt-get install e-links, and confirm that I want to install it with all the dependency. Here also apt-get install e-links and confirm. And in the firewall also, I'm going to install e-links. apt-get install e-links. Okay, so it is installed everywhere. So when you want to know what is the service associated with a port, for example, I say port 80, and you want to know that the service, you might know that the service is, for example, HTTP. But if I say port 161, you might don't know that 161 is associated with SNMP. So there is a file in Linux that is called etc services. So in this file, you will find the correspondence between a port number and the service. For example, let me go port 80, or for example, port 21 is FTP, as you can see. Port 22 is Secure Shell. Port 23 is Telnet. So if I keep going, I will see that port 80 is HTTP. The next one that we know, for example, is port 110, which is POP3. So let's go up to port 110 is port 3. Then we know port 143, which is IMAP. So if I go to port 143, I have IMAP here. Then I told you, for example, 161 was SNMP, which is Simple Network Management Protocol. So we do have a file that will give you a port number and the name of the service associated with. Okay, so let's continue. What else we need to do? We need to specify the IP address of PC2. Who know what should I do to do that? So let me go back to PC2. This is PC2. This is the window of PC2. Let me minimize the other window so it's a little less confused. So this is PC2. How do I get the IP address of PC2 in this moment? What? ipconfig, ifconfig. ifconfig, no ipconfig. ifconfig because ipconfig is the one of Windows. ifconfig will be the one of Linux. So look at, it say that in the interface ETH0, we have this IP address, 192.168.122.221. So this is not the IP address that I want for PC2. How do I get this IP address? Through DHCP. You remember that I told you that the NAT cloud have a DHCP server, and by default, the devices get the IP address through DHCP. And the name of this device is not PC2, it's Debian. I would like to change it to PC2. What should I do? Which file I need to modify? The /etc/hostname. So I'm going to go and edit the /etc/hostname. And here there is only one line that says Debian. So I'm going to put PC2 here. This is the name of the device and save the file. What other file I need to modify? At the level of the host name, there is a second file, which is the /etc/host. And here you can see that we have Debian 2 times. So the full qualified domain name was debian.jsu.edu. Now it's going to be pc2.jsu.edu. And the short name, the host name, is just PC2. Okay, I'm done at the level of the name. Now, which file should I edit to modify the IP address on the net mask and to specify the default gateway? Correct. So I'm going to edit the /etc/network/interfaces file. And as you can see, we have an entry here for the loopback interface and another entry for the ETH0 interface. What do I need to change here in the configuration of the ETH0 interface so that it gets this IP address, 192.168.0.2? What should I do here? Exactly. So here it says get your IP address in the second line. It says get your IP address through DHCP, Dynamic Host Configuration Protocol. I don't want to get my IP address through DHCP. I want a static IP address, an IP address that the network administrator is going to specify. So I put static here, and we have some keywords that we can use to specify, for example, the address. So there is a keyword that is called address, and with the keyword address, which can specify the IP address of the device. So 192.168.0.2. Then there is another keyword that is called net mask, and we want to specify what here? A /24. And a /24 in the dotted decimal notation will be what? Correct. It will be 255, 255, 2550. What else should I specify here? At the level of PC2, so PC2 can work perfectly. I need the gateway, exactly. So who is going, what IP address is going to be the IP address of the gateway? Correct. So it will be 192.168.0.1, which is the IP address of the router in this interface that connect me directly. So I'm done with the configuration of PC2, and there are different ways that I can proceed because I made change in files. I need to tell PC2 I made the change in the file, and I want to tell PC2 please consider those change. So one way to do it easily, we are going to do it that's way now, is to reboot PC2. So I can use the command reboot, and it will reboot PC2, which means that it's going to kill all the processes that are running in this moment. Then it will power off and power on again PC2, and it will start all the processes. As you can see, PC2 have started, and look, it's not called Debian anymore, it's called PC2 now. Let me enter as the root user, and let me put the password, which is tool. And as you can see, I am the user root at PC2. So now it's know that its name is PC2. Let's verify its IP address. So its IP address is 192.168.02, which is correct. Its netmask is 41/24, as you can see, which is correct. And if I want to see if those services are still running, I can do a netstat dash numerical alt TCP, and I should see 4 open ports: the 22 for Secure Shell, the 80 for the web server, the 21 for the FTP server, and the 23 for the telnet server. So as you can see, 21 is the FTP server, 22 is the Secure Shell server, 23 is the telnet server, and 80 is the HTTP server, the web server. So everything is okay with PC2. I'm done with PC2. So let's configure now, for example, PC11. So let me open the window of PC11. It is there. Please help me with that. But this time I don't want to reboot PC11. I want to make the change to the file and tell PC11 I did some change. Please take them into account. So what can you tell me? What can we do? So I need to modify this file, the hostname file. I'm going to modify it. So if we reboot PC11, it's not going to come back with the name Debian, but with PC11. Okay. There is another file that I need to modify. Is this one, etc, the etc hosts. So look, one command that you can do in VI. It's why I like VI and I don't like Nano. Look, I'm going to say in line 2, substitute Debian with PC11 in a global way. So as many times that is required, we need to do it 2 times. We have a Debian here and a Debian here in line 2. Look at that. You see? In Nano, you cannot do that. So all the command of the sed editor, the stream editor, you can put them here in VI. They are very famous in the Unix world, all these commands. So as you can see, I already modified that. I'm going to save the file. And I need to change the IP address. So before I do that, let's verify the IP address that we have in ETH0. It will be an IP address that I got through the HTTP. So it's not the correct IP address. It's 192.168.122.112. It's not the correct IP address. I want this IP address. So look, what I'm going to do is IF down ETH0, shut down ETH0. So it released the IP address to the DHCP server. It's give the IP address back to the DHCP server. So as you can see, we see a DHCP release. Tell the DHCP server, I don't need this IP address that you give me. You give me a lease of this IP address for some amount of time. I don't need it anymore, so take it back and use it for another client. So I'm not using the IP address anymore. So I'm going to edit the file etc network interfaces and put what I need in this file. So here, the same thing. I need static. I'm not going to get the IP address through the HTTP. What will be my address? 172.24.0.11, isn't it? What will be my net mask? What is my net mask? So it is in the graphic, no? Yeah, it's a /16. So it will be 255.255.00. What will be my gateway? It is also in the graphic. What is the gateway of PC11? Correct. 172.24.0.1. And what I'm going to do here now is to put the interface up. So IF up, ETH0. And if you look, I will have the correct IP address now. Look, I didn't have to reboot the machine. I have 172.24.0.11, and the net mask is the /16, as you can see. So the problem is the name. The name have not been updated. So there are different ways you can update it. So let me show you an easy way. Eric. So, well, it's longer than I thought. Maybe the easier way is, we need to type also the command host name and the device name that we want. We want PC11. Maybe the easier way is just type exit and re-enter. So I'm ready. My name is PC11. I have the correct IP address. I'm ready. And if you look with the command netstat -numerical all TCP, I will have the 4 port that should be open. Okay, the 21 for FTP, the 22 for the secure shell server, the 23 for telnet, and the 80 for the web server. So PC11 is okay. Let's do the same thing with PC31. So I'm going to edit the required file. Let me just have this window. So the etc hostname file. And here, instead of Debian, I'm going to say you are PC31. Then I'm going to edit this file. And I'm going to say from line 1 to the last line, replace Debian with PC31. 31 in a global way. So I don't have to realize that they are in line 2. It will do it everywhere. So as you can see, we have PC31. Let me save it. Let me type here host name PC31. The easier way I say we exit and we come back, so it's know its name. So we didn't boot it. Then the IP address that this device will have in ETH0 is not the correct one. He got this IP address through DHCP. So it starts with 192.168.122. All of them start with 192.168.122. Okay, so I'm going to do IF down of this interface. So it's killing the DHCP client. By the way, let's do something here now. If I do numerical all UDP, you see port 668 is not open anymore because I'm not using DHCP anymore. Okay, so let's edit the correct file, which is the etc network interfaces file. In this file, we are going to say we are not going to use DHCP, but we are going to use a static IP address. This address, this IP address of PC31 is 172.24.0.31. The net mask is a /16, so 255.255.0.0. And the gateway is 172.24.0.1. 24.0.1. Okay, so what we are going to do after saving is if up, the name of the interface, and I should verify that I have the correct IP address now. So we have 172.24.0.31/16. We are ready to go. Okay, so the only one that is left to configure is the firewall. So let's do the firewall now. So the firewall has two interfaces. Okay, so let's deal first with the host name. So the host name that I want for this firewall is firewall. Okay, let me exit. Let me enter again. So the name of the firewall is reflected in the prompt, as you can see. Just in case that we reboot the firewall, I prefer to have it also in the file here, not Debian, but firewall. And here in this file, look at another way to do it. In this line, replace Debian with firewall in a global way. So we have firewall instead of Debian now. Let me save it. Okay, so if I type ifconfig, I will show information. I will see information of the loopback on ETH0. So here we have information of the loopback interface on ETH0. We don't have information of ETH1. Why? Because it was not in the initial file. The etc network interfaces. If you want to see ETH1, you have to add the option -A for all. So it will show us ETH1 also. Oh, we didn't add the interface. We just copy. So we need to add an interface. So let me shut down the firewall and we are going to open the firewall. So let me go back to GNS3 and here is the firewall. If I put my mouse, look at it, say there is one interface. You see it? It's called Ethernet 0. You see it in the pop-up yellow, the yellow pop-up. It says Ethernet ETH0 connected to switch port Ethernet 0. So which means that I have only one interface. I need a second interface. No, it is there. There. Okay. Let me put it again. Okay. So as you can see here, we can see that we have only one interface, and this is the back of the interface ETH0. So I need a second interface. So I forgot to do it when we were configuring the devices. So I'm going to open the firewall, go to configure, and here in the tab network interface card, it says you have only one network adapter. I'm going to say I need two network adapter. I click OK. So I got a message say that I need to remove first the link. Let me remove the link. Okay, so configure, I go to network, put a second network adapter and put OK. And now if I look, you see we have ETH0 and ETH1. We have two networks adapter. So I can boot the firewall now and configure correctly the two interfaces. So should maybe have connected. Okay, it's already boot. It's already know its name. It's firewall. Let me enter as root. Let me increase the font that we are using so you see better. And I'm going to go, okay, let me type the command ifconfig this time, alone. And we have information of ETH0, but not ETH1. If I put the -A, we have information of ETH0 and ETH1. So why ETH0 did appear and ETH1 did not appear? Because in the file, etc network interfaces, we only mention ETH0. You see here, we only have line for ETH0. So what I'm going to do here is to put static. Okay, guide me. What should I do after that? So ETH0 is this one. So what should I put here? Address. What is the IP address? 172.24.0.1. What else I need to put? Net mask. What will be the net mask? It's a /16. So 255.255.0.0. Now I'm going to take these 4 lines and copy them. So 4YY on P for put, and I have a copy. I want to replace ETH0 by ETH1 here. So what will be the IP address for ETH1? And what will be the net mask? So ETH1 is there. The IP address is 192.168.0.1. And the net mask is a 4/24. So it will be 255.255.255.0. Okay, I don't define any gateway in the router firewall. No, because there is only 2 networks. It doesn't have to send to another router. So that's pretty all of it. Let's do an IF down of ETH0, then an IF up. So it should have the configuration on an IF up of ETH1. So if I ask, show me the configuration of the device with the command ifconfig, it's telling me that ETH0 have this IP address, which is the correct, as you can see. This net mask, which is /16, it's correct. And in ETH1, we have this IP address, which is the correct, as you can see, and the net mask is the correct. So all my devices are ready to go. So what I need to do now is to connect them as I want. So at the beginning, I connect them in a specific way to access the internet. Now that they already have what they need, I'm going to do the connection that I'm really looking for. So I need another switch. Let me duplicate this switch. If it let me duplicate it. Yeah, so I'm going to lose this switch. So I need first to connect. Let me unconnect those devices. Delete. Delete. Delete this connection. Maybe I do it a little smaller so we can see both. Okay, so here we will see both. I want to see my network. Okay, so what should I do here at the level of GNS3? So I need to connect the firewall to PC2. Then the firewall to a switch. Then PC11 here, and then PC31 here. So I just need to do the connections now. So let's take the cable. I go from PC2 that have only one interface to ETH1. So here we have 2 interfaces. That has to be ETH1, okay? Then I go from ETH0 to the switch, any interface of the switch, then any interface of the switch to PC11, then any interface of the switch to PC31. Okay, done. Let me put them in a better position. Okay, this is done. So I keep this here just in case that I need to install something in a device. I can put it back here, connect to the internet and grab what I need from the internet and come back. Okay, so they are here, they are ready. So what command can I use in PC2 to see that I have connectivity to PC11? Oh, by the way, I'm going to put the name of the interfaces. So with this tool, with this icon, you see the name, for example, that this interface is ETH0, this interface is ETH1, ETH0, ETH0 here, and ETH0 have appeared. Okay. In the switch, the name of the interface is not important. Okay, I'm going to go to PC2. Show me that we have connectivity from PC2 to PC11. What command do you propose to type to show that we have connectivity from PC2 to PC11? Huh? So here in PC2, I want to see that from PC2 I can reach PC11. What command? Ping. It's the basic command. So ping on an IP address. So the IP address of PC11 is 172.24.0.11, and it should work. Oh, there is something that we missed. This guy is what by default? It's a computer. So it doesn't do forwarding. I need to tell him, oh, I want you to behave as a router also. So I want you to enable the forwarding. So there is one command that I need to type at the level of the firewall, the firewall router. So it do forwarding. So this ping is not going to work until I enable the forwarding at the level of the router firewall. So who know how we enable the routing? So there is one variable. The system have a lot of variables. And all the variables, you can get them with this command. System control -A. It's a bunch of variables that have the system. So you can fine tune the core of the operating system. Look at all these variables. So it's a bunch of them. If I count them, let's count them. Word count -line. We have 1005 variables. So we can see them like that. So for example, those are variables that are related to the manage of the CD-ROM, the manage of quota, the manage, for example, of the scheduler. Okay, we have a bunch. The manage of IPv4, this is what is interesting me in this moment. And there is a variable that is called forwarding. IPv4 forwarding, not this one, this one. You see this variable? It says it's equal to 0, which it means don't do forwarding. I need to put this variable in 1, so it will do forwarding. So let me copy the name of the variable. It's net.ipv4.ip_forward. And we are going to type the command, which is sysctl system control -w for write. And I want to put this variable in 1. So as soon as I hit enter here, the ping should work. You see, I hit enter, look at the ping. The ping is working because now I told it you are a router. Let me stop it. Let's say, don't behave as a router. You see the ping have stopped. Now I'm going to say behave as a router again. The ping has to continue. Okay, it's behaving as a router. If I reboot the firewall, this variable will still be in 0. So there is a file where you can edit it. This file is called etc sysctl.conf. And I'm going to search for the line. Here is the line. So it's a uncomment or comment out the next line to enable packet forwarding in IPv4. So I'm going to do that, which means that the next time that we boot firewall, it will also be a router. Okay, so everything is okay. As you can see from PC2, we can ping PC11. Let's ping PC31 to verify that we can also ping PC31. So The IP address of PC31 is 172.24.0.31. So it should work. And as you can see, it's work. Of course, from PC11, I should be able to ping PC31. From PC11, I should be able to ping PC2. So everything is working. Now, let's create some users. All these virtual machines by default have two users, the user Eric and the user root. So here in PC2, I want to create additional users. So who can tell me how can I create a user that is called, for example, John, let's call it John Montgomery. I want to create John Montgomery. And John Montgomery is going to work in PC2. So here I'm in PC2. How do I create John Montgomery? There is a command that is called user add. It's a very low level command. So it's very good for script. In interactive mode, there is another command that is called add user. So we are going to do it in interactive mode. I'm going to use the command add user. So the user that I want to add, for example, here, look at, we have two users. We have John and Amelia. We say we are going to add John Montgomery. So I put add user John. So you say, what is the password of John? Let's keep it easy and put John, password John, okay? So it's not difficult to remember. Retype the password, John. Okay, what is the full name? John Montgomery. What is the room number where John walked? I'm not going to specify. What is the extension? The home phone, other information. Is this correct? Yes. So I did create a user that is called John in the machine. So let me create a second user. We are going to create, for example, here, Amelia. So I'm going to use add user, a command that is a little higher level, Amelia. Let's create Amelia Smith, for example. So what is the password of Amelia? Let's put Amelia to keep it easy. What is retype the password of Amelia? Amelia. The full name, Amelia Smith. Room number, telephone at work, telephone at home, other information. Okay, all this information is okay. So I have two users now in PC2. So let's verify, for example, that let's go to PC11. And let's say that Amelia today cannot reach PC2, but she is in PC11 and she needs to change something in PC2. She has an account in PC2. What can she do? She can SSH, correct, or she can telnet. SSH and telnet will do remote session. So look at what I'm going to do. I'm going to spy at my system with netstat -n or TCP, but I want to type this command every 1 second. And I don't want to do it by myself. I want Linux to do it every 1 second for me and update the information. So there is a way to do that, and it's what is the command that we use? Watch. Watch. Every 1 second, type this command for me. So look, you see, we have all the services that are opening. So now Amelia come and want to remote connect to PC2. So look at, Amelia is going to do what? Telnet, the IP address of PC2. So what is the IP address of PC2? Let's get it from here. 192.168.0.2. So 192.168.0.2. What do you think is going to happen here? we will have one additional line that is going to say that there is a new connection. So look at all the port here as a listen. Look at what is going to happen. Let me do it. So there is one additional line. This is this line. A connection has been established. So, okay. So it's telling me, please, what is your login? So I'm going to put Amelia. What is your password? Amelia. So look at Amelia is in PC2. Now, she did a remote connection to PC2. So what is this? Let's understand this line. This line say what? This line is running PC2. So this is the local column and this is the remote column. So it say there is a connection that is established using TCP from my local IP address. So this is an IP address. Let's put it to verify it. This is an IP address of PC2, 192.168.02. Port 23. What is port 23? The telnet server. So there is a connection from a remote site to the telnet server in my machine. On the remote side, I have this IP address, 172.24.0.11, which is PC11. Why? Because Amelia was in PC11 when she established the connection. And this is the port that Amelia is using. It's a dynamic port, as you can see. So this is this connection that we just established. If Amelia leave, this will disappear. So let me do an exit. Okay, I did an exit. Look at it's in time wait. And it's at one point it was saying establish it, you remember? Now it's a time wait, and in a few seconds it will disappear. Because the time wait stay a few seconds before it disappears. It's waiting to close the connection. So let's wait it to disappear. Of course, if I establish a second connection, let me, for example, this time, Amelia go to PC31. So I go to PC31 and Amelia is going to connect. And Amelia is going to create some directory in a home directory. So let me connect to PC2. The IP address of PC2 is 192.168.0.2. So I'm going to do telnet 192.168.0.2. So look, there is a new connection that is established. The other one already timed out. And look at this connection. Let me enter here. Finish the connection. So I'm going to enter. Let's enter like John, because there is another user that is John. I enter like John, and my password is John. So I'm in PC2. Look at this connection. It says locally on port 23, there is a connection. Port 23 is the FTP server. So locally on this IP address, 192.168.0.2, there is a connection that was established from this remote IP address. This remote IP address is the IP address of PC31 because John was on PC31. And the port that John is using is this port, and the connection is established. So John is here, but connect remotely to this device. And of course, I am in PC2. So if I create a directory, let me create a directory. For example, make dir, let's create AA, BB, and CC. Let's verify that we create those directory. They are there. Let me stop this. And let me verify here. I'm going to go to the home directory of John. And let me verify that we have the directory. You see, they are here. If I create a directory here, another directory, let's create DD, and I check it here, DD is there. Okay, So this is a remote session. So I stop the remote session. Let me again start the checking of the processes that are on. Okay. What is the problem of Telnet? The problem of Telnet is that Telnet is not secure. Telnet send the password in clear text. So let me just do that and we finish here. I'm going to open Wireshark in one of these two links and capture the traffic. So here you just go to the link and say start capture. And it's going to start capturing the traffic. Let me do that again. I am John. I'm going to connect to PC2. So I telnet to it. Look at the traffic. It's already reported here. And it says it's a telnet traffic. So I'm waiting for the telnet daemon to ask me for my username. It's asking me my username. Let me put John. And then he asked me my password. Let me put John because it's also John. Okay. And let me finish my connection. So look at what the hacker can have. The hacker captured the traffic with Wireshark. Since the traffic is not captured, is not in clear text, look at what the hacker can do. It can follow the TCP stream. And look, this is the conversation. When the web server asked me, give me your logging, I type a J, and a J was echoed to me. I type a O, and the O was echoed to me. I type a H, it was echoed to me. N, and it was echoed to me. When the server, what is in blue is what the server show me. When the server asked me my password, I type John. So this is my password. So as you can see, the hacker, and then I tap exit. So this is the hacker see my password because my password is not encrypted. So we don't follow the CIA model where we want to have, C is what? Confidentiality. We want to have confidentiality. Here we don't have confidentiality, unfortunately. So it's why Telnet is not used anymore. Okay, so we are going to continue this lab over two classes. So we get used to IP table. Okay, so I will pause these slides so you can repeat the lab. And on Thursday, we will continue from here. Okay, thank you for attending the class.